as I said, we are introducing some very exciting features to the FC series tempering line. And the two main features that we are now demonstrating here are the Vortex Pro convection system and the edge control technology. And to demonstrate how we are able to affect the glass quality with the edge control system, we are running two glasses. Both are run with exactly the same recipe, with one exception, which is that the first one will be run without edge control technology, and the second one with the edge control technology. So it's a very nice way of seeing what the new technology can actually achieve. And it's good to remember that the machine that we are using is the new FC series line, and it's already considered to be the top performer in the market. So it's very nice way to see how we are actually able to make the best even better. First glasses are now in the furnace. We'll be waiting for both glasses to come out before we measure them side by side. And what we are measuring is edge lift. And now if you look at the screens, you can see an illustration of what edge lift actually is. So edge lift is a phenomenon that is concentrated on both leading and trailing edges of the glass. And it's mainly caused by glass creeping between the rollers at the end of the heating cycle, and also some turbulent air movements in the chiller section. And when you have a thin glass, in this case we have a very long and narrow glass, so edge lift is very hard to control. So it's good to see what kind of impact we can get here. And why edge lift is so important is that when you're laminating glass, if you're not able to match glasses perfectly together, it means that you have a huge risk of delamination after the process. And that means then that you're effectively wasting all of that material, all of the glass, all of the PVB, plus all of the time and energy that has gone to the process before that. One interesting factor is also that if you are making fire-resistant glass, you really have to overheat the glass, and with the edge control technology, you are able to achieve much better quality than you would normally. A few words about the Vortex Pro convection technology. So now on the screens, you can see an animation of how the Vortex Pro works. And the technology allows us to profile convection efficiently where it's needed in the furnace. So you are able to set convection profiles that target certain areas of the glass. So for example, in this case, the center of the glass. And while the glass is oscillating in the furnace, the convection is actually following the glass. So we are not wasting energy by heating areas in the furnace where you don't have any glass, because that's not necessary, and the glass is always being heated in the right way. Now you can see that the first glass has already come out of the furnace. Pekka now marked it, and this is the one that was processed without the edge control technology. So it's being placed now on the measurement table, and it will be labeled so that you know that it's the same glass that actually came out of the furnace. And we'll be waiting for the second glass to come, and then the measurement will be done side by side, so you have a very nice comparison point. For Vortex Pro convection system, the main benefits are that you are able to run much more mixed loadings. So it enables you to optimize your loading efficiency, and you're able to get more capacity out of the furnace in the same time. And in an annual basis, you're easily talking about tens of thousands of square meters that you can get out of the furnace with the same time. Second thing that the Vortex Pro brings is that you're able to control your hard glasses. So meaning if you have a, let's say, large square glass, you're able to process it without any bistability. If you have a glass that has a very large edge deletion, or let's say a large edge painting on a low-E glass, so you're able to heat those efficiently without sacrificing the quality. As you can see from the image that was from the first load, it's very even, which is a result of the FC series technology that we have to control the anisotropy that is coming out of the furnace. So if you have the capable machinery, there's a lot that you can also do to manage anisotropy. Before we get to measuring the glasses, a few words about how the edge control actually works. And at the meantime, you can see the second glass also coming out. So Pekka will lift it to the table next to the first one and measurement will be done then. So in the edge control technology, we are profiling the cooling to correct areas in the glass. So meaning on the glass leading edge, trailing edge, and it's also possible to do it on the sides of the glass. And it's a very effective tool for really reducing the edge lift to almost non-existent values. And if you're a laminator, it's really a huge cost saving that we're talking about. So we have done a few calculations with glass processors, and a day-to-day laminating process is easily able to save hundreds of thousands of euros annually by reducing the edge lift. Okay, now you can see that the team in Finland is ready to start measuring. So Anna, could you talk us through the measurement and also the results?
All right, we are ready to measure the first glass, which was not done with edge control. And you see that this glass is 0.30. And this was the trailing edge of the glass. Then the other one, which was done with the edge control, shows us 0.11. So there is a big difference. And we'll also check the front end, the leading edge. And calibrate the measurement tool. And the leading edge has 0.22. And on the second glass, we have reduced the edge lift significantly, 0.08. So we have a summary here.
Okay, thank you, Anna. So as you can see, we were more than able to cut the edge lift in half, which is a very good result. And in this process, the glass was actually overheated a bit to make it a bit more challenging for us. But even so, on both leading and trailing edge lift was significantly reduced.